Hi all, welcome back to Chemical Engineering Statistics course. This is the second video for the first week lecture in which I will briefly describe about the role of statistics in engineering. The diagram that is shown here shows an engineer's way of thinking in problem-solving process, starting from the formulation of the problem, compiling a mathematical model of the problem, refining the model, to using the model to formulate a solution. Well, statistics is a science related to data collection, analysis, and delivery. Because the mathematical model in this diagram is developed based on measurement data and is applied to produce data, all stages in engineering problem solving can be supported by statistics. Application of statistics as a whole is also known as the discourse statistical thinking. The basis of this thinking is the awareness that all measurement data contain uncertainty, so that repeated measurements of the same amount will produce a spread of the measured value. Another very critical concept is our inability to conduct synthesis in many engineering solutions. The consequence of these limitations is the need for a special approach to be able to draw conclusions about the population based on the results of sample measurements that are often very limited. Now, let's review a number of statistical roles in engineering. The first role is in data measurement. Please refer to the textbook what is meant by collecting data in a retrospective study, observative study, and experimental study. In all three approaches, statistics provides mathematical guidance for data collection and processing techniques. As an example for your reflection, please think about this. Look at the figure. What variables you can measure from this industrial frying pan, and how statistical techniques can guarantee good quality measurement results. Next, in the world of science and engineering, very much utilizes a variety of statistically designed experiments. That is, experiments that regulate variables follow the rules of statistics, which prove to be more efficient in the sense of being able to produce more information with less number of run or experiments. Next, a mathematical model is a representation of a real system in a form that is much simpler and cheaper to manipulate. In modeling engineering systems, statistics play an important role in estimating the values of parameters or constants of the model, validating the model before it can be applied, and so on. The final example of a statistical application is SPC, or Statistical Process Control. In SPC, statistics are used to check whether a process is in a state of statistical control, where the variations shown in the process output only reflect the natural noise or variability of the process, not the results of an interruption that can harm the process. I close this lecture with expressions from two famous people about statistics. Edward Deming is a mathematician father of the pioneering statistics of IPC, who is famous for saying, "In God we trust, all others must bring data." While H.G. Wells is the author of the legendary science fiction novels, which illustrate the importance of statistical insight. Statistics provide a guide for us to be able to measure, process, and translate measurement data objectively, to find solutions to problems that are right and can be accounted for. That's all. Thank you and see you in the next video.